Okay, not gonna lie, I think it's really ironic that the Web3 lecture is after the lecture on making useful things. So let's get started. But first, we're gonna do a bit of story time. So yeah, I'm sure a lot of you have heard of FTX, but before FTX, there was Mt. Gox, and it was the biggest crypto exchange in the world. But Mt. Gox had really bad code, and they also didn't use version control, and they got hacked. And then they went bankrupt in 2014. So the moral of the story is to write good code and to use Git. Also, don't get hacked. Okay, but actually though, like, what is Web3, right? Like, what is blockchain? What are NFTs? And what is this word decentralization? I hope by the end of these 30 minutes, you guys will have a better understanding of what these concepts are. And we're going to be starting off with talking about decentralization and Bitcoin. And to use an example, we're going to talk about my favorite social media app, Venmo. So, in Venmo, you might have two users, Alice and Bob, and they want to have a transaction. So Alex is going to be like, hey, Venmo, I want to send $5 to Bob. And Venmo is going to update everyone's balances. And then Venmo is going to notify Bob and be like, hey, Alice sent you $5. And Alice and Bob are pretty happy with this system. As long as Venmo is being reasonable, right? But sometimes you can't actually trust Venmo. Maybe you don't trust Venmo because if you give Venmo a lot of power, they can start doing some shady things. So for example, if you had an evil Venmo, one thing they could do is if Alice sent $5 to Bob, they could actually not decrease Alice's balance, right? But they could still tell Bob that his balance increased by $5. This is, obviously arbitrarily duplicating money, but they could do this. Something else they could do. They could decrease Alice's balance by $5, and they could increase Bob's balance by only 4.9999. And they would still tell Bob that his balance increased by $5, but it wouldn't actually, and they would pocket the change. And another thing they could do is if Alice tries to send money to Bob, they could just be like, no, I don't like you. You are banned from Venmo. This is called censorship. And these are all things that Venmo can do, or evil Venmo can do. And this is because we put too much power with Venmo. Venmo is solely in charge of, or evil Venmo is solely in charge of this evil Venmo system, right? And in general, putting one person or one entity in charge, or this is what we call centralization, it can be bad. And sometimes we want to avoid this. So this is where the concept of decentralization comes. For our purposes, what we mean by this is no single person is going to be in charge. And we want, this is kind of crucial, anyone can join or participate in the system. So if we start with like 30 people and they're all like transacting, that doesn't count because no one can join the system. And for this reason, many so-called decentralized systems are not actually decentralized, but that's just so you guys don't get confused if you're reading something online with what I'm saying and what they might be saying. Basically, what we want to do is we want to put everyone in charge of these transactions. And this is going to come with actually a lot of different problems. But we're going to start to build up a system and see how it works. And the first thing we're going to do is we're going to make sure that every user has a copy of all the data in the system. And a great analogy to use is a public bulletin board. So, at the start, the bulletin board might have like everyone's account balances. And then as people make transactions, they're going to post transactions to the bulletin board. So like Alice might send $5 to Bob, and Bob might send $10 to Carl. And as long as all these transactions are on the bulletin board, everyone can verify these transactions and make sure that everything is working. As long as no one is going, below zero, everything should be okay. And this seems like it's gonna work, right? The only issue is we said it's like a public bulletin board, but it's not really like a single board because at the end of the day, the bulletin board is just data, and everyone is going to have their own copy of the data. And so sometimes people might end up with different copies. So for example, at the top, we might have Bob's bulletin board, and we see that Alice has sent $50 to Bob. But on the bottom, we have Carl's bulletin board, and Alice has actually sent $50 to Carl. But Alice only has $50, right? So both of these transactions cannot be happening at the same time. And this is what we call a double spend attack, more or less. And imagine if like Bob accepted Alice's transaction and he gave her like some goods, like $50 worth of cake, and so did Carl. Now that they've given the goods away, they've basically been tricked into accepting payment, even though it was illegitimate. And the reason for this is because each person has their own copy of the bulletin board, and they're not agreeing. So what we need for our decentralized system is consensus. We need all the participants to agree on the state of the system. Basically, we need everyone to agree on everyone's account balance. Because if you think I have $50 and I think I have $1,000, we have a big problem. Because I clearly have $903 more than you do. Okay. So what we do is use a consensus protocol to make sure that everyone agrees. And how is this consensus protocol going to work? It's going to work by voting. So more or less, people in the system are going to vote, and they're going to make sure by voting that everyone agrees. So just like how in voting you pick like a leader, you pick a president, you pick treasurer for your club, whatnot. You make sure that everyone is agreeing on the set of transactions in the system. But this is harder said than done. Like even normal consensus protocols are a bit difficult. And to demonstrate this, let's suppose that Alice, Bob, and Megamind are trying to pick a leader. But Megamind is a bad guy. So he's going to tell Alice he voted for her. But he's also going to tell Bob that he voted for Bob. And then Alice is going to vote for herself, and Bob is going to vote for himself. And the result is that they're both going to think they're the leader. And so you can quickly see how even like a simple voting thing can be very complicated. Because this is clearly a problem. We were trying to get one leader, but they both think they're the leader. And even if we could solve this voting problem, the next question we have to ask is who is allowed to vote? Like, if it's a decentralized system, we want anyone to be able to vote. But the problem with this is we run into something called a Sybil attack. So, okay, let's just say Alice, Bob, and Megamind are voting in some way. The thing is, Megamind, let's say he only has one laptop, right? But that doesn't mean he's restricted to one account because he can make fake accounts, let's say. Megamind can pretend to be two people. Megamind can pretend to be 3 people, 4 people, 5 people. He can pretend to be like 50 people, right? There's no limit to what he can do because there's no like ID system in place. That makes sense. And this is what is called a Sybil attack, where some user is making or pretending to be a bunch of different users, and they're trying to hijack a vote. So, if sufficiently many users are malicious, they're going to be able to double spend, and we need to find a way to resolve these problems. And so Bitcoin is like solves this problem in a pretty clever way. So before we said that making accounts is like very easy, right? Because even one computer Megamind can pretend to be like a whole variety of different accounts or different people. But computational power is expensive because laptops and CPUs, they cost money. And so Megamind can create a lot of users, but he can only have so much computational power. There's only so much money he can spend on CPUs, right? And Bitcoin is going to sort of try to exploit this to come up with a way for everyone to agree without this double spend attack. So to get started, so in Bitcoin, transactions are going to occur in blocks, and users are going to agree on blocks. One by one, each block has a set of transactions, everyone can agree. And to propose a block, someone needs to solve a puzzle. And this is crucial because the malicious attacker has limited computational power. So they can only solve so many puzzles at the same time. And so to sort of see this, we have block 1. This is going to be the first block. It has some transactions. Then we have block 2. It has a puzzle solution. It has the cryptographic hash of the last block. And then it has some transactions. And I'll explain what the hash thing is soon. So don't worry. And then we have block 3, some transactions. It also has a puzzle solution. And one thing to note is there can actually be multiple different puzzle solutions, right? So 2 people might come up with a puzzle solution. But in this case, we have a chain, and top chain is of length 3. So people are going to sort of accept the top chain. If that makes sense. Does anyone have any questions about that? Basically, you look at whichever chain of blocks has the longest length, and you're going to assume that one is true. Okay, so I know there's this weird like hash thing, and this has to do with the double spend attack. So let's see what happens if someone were to try to sort of go back in history and rewrite block 1. So if you rewrite block 1, the hash of block 2 is going to change because we changed the data, and the hash is like a function applied to the data. Okay, so the hash of block 2 is changed. Now the puzzle actually depends on the content of the block, and the hash changed. So the puzzle is going to change. So the solution of the puzzle is going to change. So now you have to do a whole bunch of extra work to recompute the solution to the puzzle, right? Okay, you do that. But now the hash of the next block is going to change because you just changed block 2. So then you have to recompute the puzzle solution for block 3. And then you have to recompute the puzzle solution for block 4 and block 5, and so on until the end. And so this solves the double spend attack. Because if someone were to try to rewrite history, they would have to redo all the puzzle solutions, and they just wouldn't be able to catch up unless they had like enormous amounts of computational power. So remember, longest chain is going to be accepted as the truth. So if someone were to try to make 2 copies of this bulletin board, they would have to redo all the puzzles, and this is just not useful. And then the crucial insight to this Bitcoin, it's not this whole solving puzzles thing. People call that proof of work. Proof of work by itself is not very interesting. It's sort of like a very crude consensus mechanism. The thing is, it relies on people solving all these puzzles for no reason, right? And like, who is going to just have like a computer like sitting there just solving these puzzles for like no reason? No one's going to do that, right? And so the crucial insight to Bitcoin was it provides incentives. It's hard to pay people to do this work, right? Because that's expensive. But here's the thing. You're operating a currency in theory. Bitcoin is going to be a currency. And so what you can do is you can pay people in the very currency they are operating. And this is why Bitcoin is very interesting, because this is what Bitcoin mining is. Now, I went through that very quickly, so it's okay if you didn't understand all of it. Just know that Bitcoin is mostly about consensus and proof of work and mining. That's the high-level overview. Okay, so now we have a decentralized money system. Great. Okay, major spoilers for Harry Potter book 4. So at one point, okay, wait. Before, I just want to point out that any like magic system or any that 29 nuts in a sickle and 17 sickles in a galleon, okay, they deserve to get it replaced with like a cryptocurrency. I'm just pointing that out. But okay. Anyways, some point in book 4, Fred and George make this like ridiculous bet with some like guy like Ludo, I don't remember his name, right? And then he's like, hey, these guys are idiots. I accept this bet. And then he's like, I lost. Because he lost. And then he paid up. But he actually sent them counterfeit money or something. And then Fred and George were sad at some point later on in the book. And if only there was a way to solve this problem. I mean, like, sure, like Fred and George could have like gone and made some like sort of like formal like lawyer up like contract, but like this is like the wizarding world, right? Like this is like the government literally supported Voldemort. Like we can't like trust the government, okay, or lawyers in this case. Like they need something decentralized. And if only there was a way to solve this problem. And along came like this guy. His name was like Vitalik Buterin, and he was like, I like Bitcoin and I like code. Let's put them together. Let's marry Bitcoin and code. And we get this hard. No, we get something called Ethereum. Ethereum is basically Bitcoin with code. That's all it is. And what you can do is create a smart contract. A smart contract holds code and data. And before in Bitcoin, you could only send money from person to person. Well, now you can send money to a smart contract. And by sending money, you can send it like 0 like Ethereum, and you can still like trigger the code. And once it triggers the code, this smart contract can do computations. It can make transactions and send them to other accounts. It can even trigger other smart contracts. And it can do a whole bunch of complicated logic. And to give you like a very basic example, I'm going to show you a piece of code, this very simple Ether bank contract. I promise it's not too bad. So at the top line, on line 3, we have a mapping. This is just a dictionary. And it's a dictionary between 2 types, addresses and 256-bit integers. Now, an address is just like a user ID, basically, in this case. And it's going to be called boxes. And we're going to have sort of 2 functions to give them as 2 different API endpoints that people can send money or transactions to. We have a deposit. And in this case, we can read this code. So first we have a requirement. This deposit is not going to run unless it's true. And we are requiring that masters.value is greater than or equal to 0, basically. And if it is, what we do is we increase the balances of the message sender or the person who sent the transaction by the message's value. And then we have a withdraw function or a withdraw endpoint, if you will, with an amount. And again, we're going to require that the amount is less than the balance that user has. The user is going to be the message.sender. And then finally, we decrease the balance by the message.sender. And then we transfer them the amount. And this is a very like basic example, right? You're just sending money and then you can withdraw it. But you can do a lot of really complicated things. For example, you could set up like a loan payment system where you would periodically send money to like a loan contract and it would calculate the interest for you. And then it could then pay out that interest to people who like gave you the money for the loan in the first place. Or you could make a smart contract for the bet between Fred, George, and Ludo Baggins, or I don't remember his name, whatever. You could make it so that it could somehow verify the outcome of the game. And depending on who won the game, it would send the money to either Fred and George or to Ludo, whatever his name was. And so smart contracts are pretty useful. Now I'm going to get, next question is, what is Ethereum Gas? So I know we said we love code, we love Bitcoin, we love the smart contracts, but imagine if, we all know that one guy who likes to like mess with things, and imagine he made a smart contract with this piece of code, and it's just like wild true. There's somewhere in the code, there's just like an infinite loop. Then, first of all, the smart contract cannot complete, right? And this is just going to be wasting everyone's time because everyone who's like running Ethereum is just going to be running this infinite loop. And, that's kind of bad, right? So, okay, fine. We have an infinite loop. So what if we just stopped it in the middle? Because we don't want to be running infinite loops forever and ever and ever. That's bad. Well, we can't actually stop it in the middle, right? Because this one, it isn't actually doing anything. But let's say we had a slightly more complicated example. What if we had 2 accounts and we were sort of sending money from account 1 to account 2 and account 2 to account 1? And depending on when you stop the loop, it would change which account had how much money, right? And so what you would end up is a situation where everyone would like agree on the set of transactions, but they wouldn't agree on how much money is in each account. And that's pretty bad. Again, you think I have 50 bucks and I think I have $1,000, we're going to have a problem. Okay, so we can't just stop it in the middle. That's a bad idea. Okay, so what if we just detected infinite loops? Well, it turns out this is impossible. If you want to learn why, you can take theory of computation, but you cannot just detect an infinite loop. And it doesn't even matter if it's infinite loop, right? Because instead of making infinite loop, you can just make it something that takes really long. And then people will be stuck doing this computation like forever. And we want to avoid this. And the solution to this is called gas. So we make people pay for gas. So when you run a smart contract, it consumes gas. Every single operation you do, every like piece of code you execute, every line of code, let's say, it consumes some gas. The more expensive the line of code, the more expensive the gas requirement. Now, if you run out of gas in the middle of your execution, you're going to reset all the changes. And the thing is, gas costs Ether. Ether is like currency of Ethereum. And so if someone is like free to submit infinite loops, but here's the thing, eventually they're going to terminate. Because of this gas structure we're using, they're all going to terminate at the same time. So it solves that problem. And the last problem is it's going to be expensive because if they submit an infinite loop, they're going to have to pay a lot of money in gas fees. Okay, I'm going to finish it up with just some vocabulary so you guys know more about Web3 things. Okay, so what is a stablecoin? Stablecoin is something that just always costs $1. Side note, algorithmic stablecoins are, I'm pretty sure they're impossible. Before there was something with like a Terra and a Luna, and they sounded like nonsense when I read it, and then it was nonsense. So, yes, okay. Tokens. So what is a token? You might have heard of tokens. It's like an FTP token at some point. There's a bunch of different tokens that are lying around. So remember, Ethereum, you can basically store data, right? And so a token is just you creating your own currency within Ethereum or within another, like a different sort of blockchain. And really all you need to do is keep track of how everyone's balanced, right? You need to keep track of how many tokens each like user sort of has. And that's really all you need to do to have a token, to be honest. So it's going to be more complicated than this, but it's not going to be actually that different. You're going to need to add more like capability so people can like swap tokens and people can exchange tokens at different rates. But at the end of the day, you're just keeping track of the balances of every user who has bought your token. That's what a token is. And again, users can exchange tokens for other tokens, Ethereum, things like that. It's just data, and you just created a virtual currency inside your virtual currency. So why would you make a token? Okay, not gonna lie. I'm pretty sure most tokens that are online are probably scams. So a good example of this was the FTT token from FTX. And I'm still not exactly sure on how it worked. But basically, instead of getting like currency back, they would give you FTT tokens that you could do various things with, like trade or buy assets with or whatnot. But the thing was, when you create your own token, you have full control over what the initial supply is. And so basically, if you create your own token, you can manipulate it to your will. And so it turns out that a lot of tokens are pretty shady, but there are some legitimate reasons to have a token. One use case is a stablecoin. A lot of stablecoins are like tokens on Ethereum, and they're always going to cost $1. Another reason you might need a token is to allow for cross-currency exchanges. What this means is if I have like some Ethereum and I have some Dogecoin, there might be a token representing Dogecoin on the Ethereum blockchain. And this will allow me to sort of exchange Ethereum for Dogecoin with some complicated logic. And sometimes, in theory, you can have a token that represents something real. And I'm going to give you what I think is a pretty good example. So let's imagine that like Alice had like a mortgage loan, okay? And let's say I owned 5% of that mortgage. So whenever Alice made a payment, she would give me 5% of that payment would go to me because I own 5% of that loan. Now you could just have it be a loan, right? And it could be assigned to me statically. But instead, I could create a token out of this loan. And I could choose to sell my ownership of this loan to someone else. And this would be a good use case of a token. Again, yeah, so you could have a token represent a stock, a bond, or just partial ownership of the loan. And then finally, what is an NFT? An NFT is a non-fungible token, but what is fungible? Okay, so I think fungibility is best explained through examples. So cash is fungible because every dollar bill, every $100 bill, more or less, it looks the same. Like the store might have like a couple of fingerprints here or there, but more or less it looks the same. It could have been used for like some sketchy things, like even yesterday, for all I know, probably not, maybe like years ago, but I wouldn't know that. It's more or less replaceable with any other dollar bill. Bitcoin is actually not fungible. And the reason for this is you can actually, I didn't explain this, but you can sort of trace back the history of a piece of Bitcoin. And you can go back and check the history. Who had this piece of Bitcoin and when? And so if that Bitcoin was ever used for like sketchy purposes, you could sort of learn if this was true. And people, assuming in some hypothetical world, people are actually accepting Bitcoin as payment, people might not accept their Bitcoin because of its sketchy history. And so Bitcoin is actually not fungible. An NFT is a token that you actually want to be non-fungible. It's like non-fungible on purpose. And an NFT token can only have one owner at a time. There's only one unit. And so it's like sort of fungible by default because there's only one of it. And you can sort of non-fungible by default. And usually they're used to represent art for some reason, ownership of art. Okay. So if you wanted to make a Web3 app, things you would need to learn probably are Solidity. So you can learn how to write code for Ethereum. And you would probably need to learn some cryptography, just a little bit. But it's also good practice to learn cryptography or like security-based thinking, especially when you're writing smart contract code, because it's very easy to mess up smart contract code. And if you have a bug in your smart contract, someone can just sort of like trick your smart contract into giving you all their money, and that's pretty bad. So don't do that. And finally, I want to end off with why Web3? Why are we talking about this? So, you know, a lot of Web3 is kind of sketchy right now. But there are possibilities for the future. You might have, there is a world in where mortgages are going to be stored in the blockchain. Personally, there's no more physical signatures in the world. I hate whenever you have to physically sign a document because anyone can forge my signature. Like, I don't get what's the point of me signing my name. And like when someone could just like forge it, like it's completely useless. And so you might imagine a world where contracts are actually represented in a blockchain. And another possibility for the future is maybe some sort of peer-to-peer lending, where like people loan money directly to each other instead of going to a bank. You know, these are all hypotheticals, but hey, it could happen. You don't know. But like the final reason, and the reason why I spent the first like 15 minutes really rushing through Bitcoin is we all like democracy, right? Like if anyone suggested that, you know, United States should give up on democracy and elect a dictator, you'd probably be wrong. But why aren't we democratizing money, right? Like we have all these banks and they're sort of all doing their own thing, right? Like, do you know how many like You know how much money laundering Deutsche Bank has done, or like Goldman Sachs? Like, it's like these are like not trustworthy like entities, and we have no reason to trust them. So it is a reasonable goal to try to sort of democratize money. And even though a lot of Web3 things are sort of sketchy right now, maybe within 10 to 15 years we can sort of achieve the true goal of democratizing money, which is why I spent the first 15 minutes sort of talking about Bitcoin, because that consensus mechanism is sort of the underlying all of this so-called democracy.